Hi, and welcome to Meetings in Math. Thank you so much for joining us in solving one-step inequalities. Today we're going to look at solving one-step inequalities using inverse steps. So how can I use inverse steps to solve a one-step inequality? And how can I determine the correct inequality symbol to use in the solution? Today you'll need your Jaguar Jots. It will say 4.2 and 4.3 at the top. Page 5. And you'll need a pen or a pencil, and a highlighter might be helpful, along with your positivity, your dedication, and your determination to do your best in this lesson. So let's dive right in. Remember that a solution step of a one-step inequality is a new inequality with the variable isolated to one side. And so instead of memorizing a whole new set of rules, we're actually going to use what we know about solving equations to help us solving inequalities. So the first step that we're going to do is we're going to change it into an equation and just solve it. What we're looking for is the boundary. Once we know the boundary, then we can determine which side is true and which side is false, and then use what we know about inequalities to finish writing the inequality. So if we look at this right here, we go back to our rules about solving inequalities to do this. So x minus 7 is less than 12. We go ahead and we write it as an equation. X minus 7 is equal to 12. So we just solve the one-step equation. I'm going to add 7 to both sides, and x is equal to 19. So what we found was the boundary point between the values that work in the inequality, which is the solutions, and those that don't work. So what we want to do is we want to set up the boundary point. So we make our number line, and we figure out, is this going to be an open circle or a closed circle? And then we will start working on finding our true and our false points. So at 19, what I wanted to do is set up my number line and make sure 19 can show up on it. So I'll make this 15 and then do the downbeats. 1, 2, 3, 4, 5, and then the downbeat again. 1, 2, 3, 4, 5, and make this 25. And we know at 19 something happens, so 15, 16, 17, 18, 19. And we have to ask ourselves, is this an open circle or a closed circle? And the way that we do that is we look back right here and we determine that that is an open circle. So go ahead and make sure you write that for now, just to make sure that you're doing the right thing. So there's nothing to do on that. We just leave it the way it is. So now the next thing that we want to do is we want to determine if we are on true side or the false side. So imagine that there is a net. And so I need to determine, do I want to make my net go this way or this way? It's in yellow because it's not actually part of our solution. Okay, it's just our imagination. So which way do we want our net to go? And that is going to help us determine which direction to cast our arrow. So we pick any point that we want. It doesn't matter which point we pick. It's just one of the points to the left or to the right. I like 0 because 0 is usually nice to work with, but it can be any point we want so long as it is not the boundary point. So why don't we pick, I don't know, 15? 15 sounds like a nice point. So this is going to be our test the point. So we're going to let x equal 15, and we're going to put it into our inequality. X minus 7 is less than 12. So when x is equal to 15, we're going to test it in the point x minus 7 is less than 12. So every time I say an x, I'm going to put a 15. So is 15 minus 7 less than 12? Well, 15 minus 7 is 8. Is 8 less than 12? Yes. So if it is true, that means it is part of the solution. If it had been false, then it is not part of the solution, and it's the other side. So here it is. If it's true, you found the solution side. If it's false, it's the other side. So since it's true, it goes over that. So this side is true, so this is the true side, and this side is false. So our arrow goes over the true. So now we need to write the inequality. So how do our numbers, so these are all of the numbers, so how do all of the numbers, or the x's, compare to 19? Well, all of the numbers are less than or smaller than, so the x's are less than 19. So The solution is that and the number line. So let's look at another one where we're going to just go through the whole problem. Let's look at number 1 on the next page. So the first thing that we want to do is change it into the equation. So we're going to change it into x plus 8 equals 18 and solve it. So we're going to subtract 8 from both sides and we get x equals 10. That is the boundary. This right here tells me it's a closed circle. So at 10 I have a closed circle. Then we are going to test a point, and it can be any point I want so long as it's not the boundary. Test a point. And I'm going to test the point so long as it's not on the boundary, I'm fine. So I'm going to test the point 7. X equals 7. And I put it into the original inequality. X plus 8 is greater than or equal to 18. So 7 plus 8, is that greater than or equal to 18? 7 plus 8 is 15. Is 15 greater than or equal to 18? The answer is false. So this was my tested point right here. That's false. So I have to shade away from it because it's not part of the solution. So it's this. So how do my x's compare to 10? My x's are greater than or equal to 10. Let's look at number 5. I want you to go find the boundary right now. Just go find the boundary. So you should have gotten that m was equal to 1. So that means at 1 you have a closed circle because this right here is closed. So now you need to test a point. And so long as it's not 1, I don't care what it is. So let's test x equals 5 into negative 4. M is greater than or equal to negative 4. So that's negative 4 times 5 is greater than or equal to negative 4. Negative 4 times 5 is a negative 20. Negative 20 is less than or equal to negative 4. That is false. So we cannot go over 5. 5 is right here. So we have to go the other way. So how do the m's compare to 1? They are less than or equal to. So that's how you do solving inequalities in one variable. You find the boundary, then you graph the boundary, then you test the point, then you graph the solution, and then you write the inequality. Okay, you are going to continue practicing these. These take a lot of time to practice, so this is all about practicing. What I would like you to do is I would like you to practice number 2 and number 6. Those are the 2 I'd like you to practice. I'd like you to practice those right now and then come on back and check your solutions. Okay, check your work. You may have tested a different point than I did, and that is okay. What you want to check is that you found a boundary and you graphed it. You tested a point. You figured out if it was true or false. You graphed your arrow and it's going in the same direction, and that your inequality is the same. This is a lesson that can be taught in many different ways, and so if you watch a different video, you may see it taught in a very different way, along with some very different confusing rules. So just be aware that you can see it in a different way. Thank you so much for joining us, and remember, be kind to each other because we can all use some extra kindness in our lives. Bye for now.